So I've just been designing a new quadcopter. This one's for 8-inch props, kind of inspired by the Blackout 360. So it's 360mm diagonal. But what I was thinking is it'd be cool if I actually could show you guys how to make your own designs, and kind of show you the process that I use when I'm designing quads. Basically, just since I discovered this, I mean, I have not bought anyone's quadcopters. There's so many people out there making their own quadcopters and they're selling them, which is awesome. And I just prefer to make my own and get them cut because it's a lot cheaper and I get to have exactly what I want, and it's unique. So yeah, in this video I'm going to show you guys how to do that. The program that I use is AutoCAD. There are other software packages out there, but this is what I use. And honestly, I have not thought this video through at all, so it's going to be a little bit patchy and probably confusing, but you will get the idea. So, firstly, what I do is I work out what prop I actually want to use. So, for this video, let's go a 7-inch prop, just because it's super unique and, I don't know, not something that I don't know any frames out there that use 7-inch props. So what I do first is I go 7-inch to millimeters, because inches is useless to me, to get the prop diameter, and that's 177.8 millimeters. Then I'll go to the trusty calculator, and so what I actually do now is I round that up, because you always want to have the prop a little bit too big in your drawing, just because if it's a bit too small, then the prop might hit things, whereas if it's a bit too big, then it takes a bit of extra space, whatever. So let's round that up to 178. So let's go 178 divided by 2. 178 divided by 2. So that's 89. So then what I will do is go to my drawing, select the circle tool up here, and for the first circle in this, you always have to choose the location. And what did I say, 172? No, I'm confused, sorry. 89. Can't talk and draw at the same time. 89. Okay, 89. So that's our first prop. That's how I always start. Now, I am far from an expert in CAD, so I literally taught myself how to do this because I wanted to do frame designs. So if I want to get to this point here, I'll just draw a line and then I'll delete that line later. So what I do now is draw a line that way, and then I will draw a line. So now I've got that line there, it lets me lock. Now that's probably an easier way, I don't know. Also with AutoCAD, it won't lock to the axes like, oh yes it will. See, sometimes it doesn't, and sometimes you actually have to go into the middle and then draw it up from the middle. See, now it's not. See that? See, there's probably some kind of consistency that I'm missing, but anyways. Right, so I will do that. Now, I'm going to have an H frame, and I'm going to have a prop up here, 2 props here, and the body's going to be this way. That's just how I'm going to design this frame. So, distance in between props. For 7-inch props, I'm thinking I would probably go 10 millimeters, draw a line. So these are just all marking lines that I delete later. And then I'll actually draw up 89 again. And so that 10 millimeter distance there, if I was going to make a frame for 3-inch props, for example, I would only make that like 5 millimeters. But I mean, realistically, the bearings aren't going to give out that much slop that they're going to hit. So you could probably even go 2 millimeters. I don't know, but I like to be, better to be safe than sorry. Okay, so then I've drawn the second prop. Now, if you want like a 250 quad and you want exactly 250 diagonal, then you can use some trigonometry to actually work out how far you need to go this way, how far you need to go that way. But the way I base it is just, I've got X amount of gear. I want to fit I'm just going to get out my ruler and measure the Y right now. So the Y is about, I don't know, 60 mil wide. So if I want to fit a Y in there, let's just go 80, because that leaves 10 on either side of the Y between the props, so that should be fine. That won't hit. And then again, I will go 89. I'll draw another circle. Then I'll go up to the top. And then I'll go up here 10. And then I'll go 89. Okay, and draw a circle like that. So that's, I mean, that is the basics. That's how I start. Then I would probably think about how I want my body design. I mean, there are so many factors. I mean, do you want the arms to come straight? Do you want them to go like an X? I'm going to show an X because that's pretty cool. And it's an extra step, and I guess you can just leave that out if you don't want to have an X frame. So I'm thinking if I come in like 5mm here for the body, how far am I going to need to go so the U doesn't see the props? I'm not sure. Let's go 40. Five in, then 40. So maybe that could be the front of the quad, do you reckon? Now what about the back? How far do we want to come out the back? We don't need to go that far out the back. The only thing is the balance, really. Now, I guess it depends what kind of style. Do we want to have the battery in the quad, or do we want to have the battery on top of the quad? Probably on top, because in the quad takes up more space. You know what, I'm going to have the back end there. Or is that going to look funny? I'm not going to have the back end there, actually. I'll have it end a little bit further back. So what I'm going to actually do now is work out the motors. So let's just say we're going to use, I don't know, my RC Mart. That'll do. Just because if you go to the website of pretty much any motor, like all 2204s, 2206s, 2208s, all have the same mounting pattern. So you go to that website and then you can see exactly what you need to do as far as mounting. So what we need to do here is the circlip. Okay, it doesn't actually say how big the circlip is, but how big did I do it on here? I know I did it a bit too big on here. 5mm. Let's go 5mm again for the circlip. So this is the hole for the circlip. Program only lasts 10 minutes, so it did cut me off. So I have to backtrack a little bit. So I've just kind of Control Z. So we've drawn the circlip hole. Now we need to draw the holes for the screws to go for the motor mount. There is a trick here because the wire comes out one direction and two of the holes are further apart than the other two holes. So you've got 19mm for two of the holes and 16mm for the other two holes. I believe it's a standard, but I'm not really sure. So yeah, maybe look at the motors that you're going to be using. But the other option obviously is to do elongated holes. Probably if I was going to do elongated holes, I would actually go ahead and go half of 16 is going to be 8, and half of 19. Oh, hang on, I'll just draw the hole there. So I always go 1.6mm diameter for the holes, just because I think it's better to have them a little bit too loose so your screws go, I say diameter, I mean radius, sorry, so your screws go through nice and easy. And what was the other one? 19. So 9.5 9.5mm radius. And I'm just scrolling with my scroll wheel here. I guess I'm doing a lot of things I'm not telling you guys what I'm doing. So that there is, yeah, 2 holes there. Now what I would actually do is go, try and get that to lock, and then go to the outside, and go like that, and bring this to the outside, and then go like that. Now the tricky part is actually deleting. This has to be done a lot as far as I can tell. Okay, I did that way too quick, sorry guys. If you've got a circle and you want to delete a section of that circle, you can go to this modify bit, and this here breaks apart some of your circles. So I click inside the circle and then I go around it to the point and it kind of locks there. You click and it breaks that part off, or gets rid of that part. Now there's this other tool, break at point. This only works if you've got an incomplete circle. You can't use that one straight off. So now I click there, and then click there, and I click on the rest of that and just hit the delete key. Delete these bits, and I want to do that same break at point tool here. There we go. So that's like an elongated circle. And you know, I never design my frames like that because I always know what motors I'm going to be using. But I might actually do it like this just because if you're using 1806 motors or whatever, you're going to need to have different spacings. If you want to account for that, I don't know, I guess you can work out how to do that from what I've just shown, I hope. So what I'm going to do now, okay, see, this tool's really handy, the mirror tool. You only really have to design sometimes if you've got a pure X frame, you only have to design a quarter of a frame, then you can mirror it over twice. And I'll show you kind of what I mean. So I've got this here which I've designed. I obviously need one on the other side exactly the same. So I select my piece, I guess. I click the mirror tool. No, I've already done that. Click the mirror tool. Now, I have to click the middle of the circle because that's the part I want to mirror it from, if you know what I mean. And yeah, you can mirror it at different angles. So, oh, in fact, I didn't know you could mirror it like that. That's kind of cool. If you click the, see how you've got, it says 46, now it says 41 degrees, that degrees thing that's moving. If you hit the tab key, that goes over to the degrees. Now type 45, erase source objects, N, because we want to keep both there. And yeah, this can save a lot of time. Now when I'm selecting things, it's a little bit different to SketchUp because you select things and you just keep clicking on things and more things get selected. If you want to deselect, you click escape. That deselects. Right, so select those two, click a mirror, click on that middle point again, and I'm going to go to tab and then 315 degrees. Now I've got to work this out. I guess 360 take 45 is going to be 315? Yeah, 315. No. There you go. So now we've just drawn those holes for our motor mounts. Still got a bit of time recording. Now at this point, what I would do is, because the cable is going to be coming out this side here, or you know, out one of the sides. So what I'm going to do is I'm actually going to use the rotate tool. So you select all your things, you click rotate, you click on that middle point that you want to rotate from, and then I'm just going to type 4 or 5 into my keyboard. So that's 45 degrees. So now we'll have the cable coming out this way. Now the other thing is, well, the outside of the motor mount, I guess. Now I always just go for a circle, like so. just because I think that's the strongest way. You can get fancy and have whatever shape you want. I just like having a tight circle. And as far as crashing and breaking motor bells, that's never happened to me. So I mean, if you're flying on concrete and stuff, yeah, that'll probably happen. But I don't know, if you're careful with the way you land and stuff, and I don't know, careful where you crash, if that can be a thing, then that's fine. So 26.6 is this particular motor's diameter. Oh, yeah. So I don't know, if we just go like a radius of 14, that gives us 28 diameter, and that's a little bit of motor protection. So that's kind of that's good enough for me. Alright, so now what I'm doing is drawing lines just to mark the outside of the arm, because then what I want to do is I want to draw a line that goes like this. And you know what? Before I do that, I actually want to, if I ever want to mark the center of the quad, what I do is I click there with a line, click there with a line, and I got that, and now I know that's the center of my quad, and I can use that as a reference point, so that's why I do that. When I'm making the holes for the Naze 32, I'll go from this point. So the reason I've done that is because I want to have a line up here, because that way I can just do half a quad and then mirror it over. Now, so I'll draw these lines straight to there. So, bam, you've got an arm. Now, if you want like a unibody frame, that's super easy because you can just design this whole thing as a bottom plate. If you want to have bolt-on arms, then you've got to take those arms away later. So, I guess I have bolt-on arms because it's a bit more involved, and you probably need to know how to do that. So, let me think. So where's the body going to end? Did we decide 5mm away from here, from the prop? Let's go 5mm. I mean, that's a reasonable amount of clearance. Yeah, I think that's probably a good way to go. I mean, you can have closer, further, whatever you think. Just this design, that's what I'm going with. I think I'll have the quad end here. I'm just trying to rush this. I'm not really being too artistic with it. And you know what? I'm going to mirror it down. I'm actually going to mirror this down because it's going to be quick. So I'm going to make this come out like 20 and then go across. It'll be super easy and have a really quick design. Okay. If I'm going to be mirroring it, I'm actually going to draw a line there. So that's kind of put my boundaries at just here. And I can just mirror it across 4 times. Super easy. And you know what? You can do that and then you can change things later. Okay, now for the arms, sometimes what I'll do is I will actually go, to the arc tool, and I'll go to this start end angle arc. There are heaps of different ways of doing it, as you can see, but I like this one. You click on your first point, you click on your second point, and now you can create an arc. Just to thin the arms out in the middle a little bit, save a bit of weight, make it look a little bit better. Now I usually kind of eyeball it, but then look at the degrees and actually type in the degrees that I want. So for this one, 7-inch props, I'm probably going to have a beefy motor on it, like a 2212 or something. So you don't want to go too crazy. Maybe 14 degrees. Start end angle, first point, second point, 14 degrees. And then I generally delete those extra lines. So that's where we are. I'll delete those lines because I don't think we need those at this point. Now, something we've forgotten is we need to get rid of this line in here. In exactly the same way as we did it for these little guys here. And I'll delete that there. So, so this is a trick. You can't have that kind of thing. That'll mess up the CNC machine. So what you need to do is decide which way you want to go. Do you want to go under or do you want to go over? I'm going to go over, and then what I'll do is that, and then you can delete that piece there. Now you see that connects nicely. And do the same here. Yeah, you can't have like overlapping lines and stuff like that. That just does not work. So it's a bit of a trick, and I'll show you when we finish the drawing how you can kind of actually discover this kind of thing if you've missed it. Now these are going to be bolt-on arms, so I'm going to decide on how I want my arm pattern, bolt-on pattern to look. Yeah. So what I'm going to do is I'm going to come in a little bit from the edge, maybe. I think 3mm looks. No, how much? I'm going to go 4mm. 4, and then I'm going to come out into the body. Maybe 4. I think that will look okay. 4, and come into the body 4. So as you can see, my design principles are like, will that look okay? Yes, that will look okay. Does it look strong enough? Yes, it looks strong enough. There's a computer thing called FIA, and it like analyzes the strength of your frame and stuff. So that's pretty fancy, but that's not really. That's just way above what I need to do. I mean, this is going to be over-engineered anyway, I believe. I'm going to go 10mm for the second bolt. No, I'm not. I'm going to go a bit further, because when you draw the circle, you know, it always goes in a bit further. So I'm going to go to the end of there, then go 10mm, then go 1.6, 10, 1.6. Oops, that was a mistake. 1.6. You need to hold the mouse in the direction that you're going to be drawing into. Now the advantage of doing that is I can just go like that, and it will lock to the hole size that I need. Delete the extra marking lines. Marking line there. Yep. So, looking at that whole spacing actually looks too far away. If I was going to get this cut out, I would actually bring all these holes a bit closer together, personally. Now, where do I want the arms to kind of go? Maybe 22mm. And I don't know how far that needs to come down because I don't know that length there. What is that length? 28. But you know what? I know that's 22, so I'm going to go 22 this way. And then lock that there. So that's an arm. Yeah. Now, I would generally round here off. How I would do that is I would go like this, maybe go 5mm in, and then come 5mm down with another line. Now, I believe you can do it with an arc, because it's exactly 5mm each way. If we go like this and then go out 90 degrees, then we've got a nice round instead of square. I mean, that's just aesthetics, and you're not even going to see it, but that's how I do that. 90 degrees. Again, typed in with the keyboard to get it exactly right. Now, when it comes to actually fixing that, I usually just delete those and redraw the line, depending on the circumstances, but that can be easier than actually cutting with those tools there. So there you go. That's an arm. Pretty cool, huh? Now I'm actually going to go and round these. I don't know if I'll end up having this exact kind of design. Yeah, I will, because this is a basic tutorial. So yep. No, wrong way. So that's the other thing. You have to actually, if you start from there and go to there, that's the wrong way. So you start from that one and go that way. 90. Redraw those lines. So there you go. Let's say we're going to have our nays right in the middle. The hole spacing for a nays 32 is 30.5 millimeters each way. So that means what you got to do is you get your line tool and you go up 15.25, then you go across 15.25, and that's where our hole will sit. 1.6 millimeter hole. Now, if I was just going to be designing this whole frame, then I would go 15.25 that way, 15.25 that way, 15.25 that way, to get all of the holes around there. But because we're going to be mirroring, I won't bother with that. What else to consider? I think this is going to look too thin in the middle, just looks wise, and yeah, maybe strength wise. So what I actually want to do, kind of want to come out here a little bit, maybe like 15, and then I want to go like 10, and I actually want to get the arc tool and grab that and go like this. Maybe let's go 17 degrees, because I think that's going to look better. Yeah, it's a whole heap of wasted space, like it's a whole heap of extra drag, I mean. But it's going to look cooler. See, when you're designing frames, it's like there's going to be a percentage that's looks and a percentage that's practicality. I shouldn't have done that, because I need a line there for the actual frame. Now, is there anything else that I want on the whole frame? I'm trying to change my mind, because I'm thinking maybe I want to go around like this. So I'm going to come out even more, and I'm going to get an arc. Always get that. I'm going to go a little bit this way. But no, 10. I believe there are better ways to get contours in AutoCAD. I don't know how to do it. That's going to look crap. What I'm going to do is go a little bit less. 2.5 mil out. And I'm going to get an arc. And I'm going to go... maybe, yeah, 9's good. It's going to look a bit better, I think. Maybe. Or is that going to be too pointy? That's going to be too pointy. 15. I think that'll look good. Oh, okay. Now, if we're happy with our arm, what I would probably do at this point is actually get this arm into a different drawing. Any separate pieces, you need in a different drawing. So what I'm going to do is save as, and I'm going to save it as tutorial quad arm. And then what I'm going to do is actually delete everything out. Wait, when was the last time I saved? Oh shit. Okay, I'll probably fucked that because I didn't save. Okay. Save as. Okay, this can be the arm, and I'll save this as body or main. Oh man, that was real stupid. Okay, so this one's the main one. Now if I go open, that was a bit of a roundabout way of doing things, but anyway. So now I've got two drawings. I've got the arm drawing and I've got the main drawing. I'm gonna save the main one right now. Okay, now for the arm drawing, I'm gonna delete out all the excess parts, and bam, that's my arm. So now what I'm going to do is I'm actually going to save it as a DXF because this is my final arm. I know that's, you know, that's not going to change. So what you got to do is you go save as, and what you need to do is save it as a DXF file. Some cutters might take DWG files, I don't know, but I've always gone for a DXF file, and the way I was taught was to use the oldest version of the DXF format, because some people's CNC machines won't handle the newer versions of DXFs. So that was how I've always done it. That's how I've always done it, sorry. And yeah, so save that as a DXF to be sent away. Now, for this, what I would do is I'm going to mirror it over now, because that is good enough for this tutorial. Mirror. And you want to mirror that. See, now sometimes it locks, and sometimes you've got to go up like that, and then click. We do not want to erase the source object. How much time have I got left? Heaps. Then I'm going to mirror it down the other way. I'll choose from there, sorry. Okay. Bam! We just made a quadcopter. Well done, people. Delete those marking lines. Oops. Wow, so many marking lines. Duplicate lines, I believe, may be an issue for some machines or something, cutting machines. But I don't know if they just get fixed when I send off the files or what, but I don't know. Maybe I have actually deleted all the lines. I always figured I'd probably missed some because they're kind of hard to find. But anyways, what are we going to do next, peeps? You might want to think about where you're going to put your camera. So if we were going to put a GoPro or a Mobius at the front, you might want to do some straps. So I always need to find a reference point when I'm going to, put things places. Let's go from here, maybe? I'm going to go from here just cause. Now, disclaimer, this is not 100% thought out. I'm just doing it for the purpose of the tutorial. Okay. So, let's just say I want a strap along here, and then maybe have one behind there as well. What I would do is mark it out like that. For straps, I always go 1.5mm diameter, because that's enough to fit a strap. 1.5mm diameter. Grab the line and go like that. Experts on CAD are going to be like, no, you're doing it all wrong. Yeah, I know. Taught myself. And then I'll get rid of those lines. But I mean, you can see though that even though I'm no expert on CAD, you can work out ways to get the job done. And I've made heaps of frames, and it doesn't take that long, even though I'm probably doing it wrong. Like, how long has this taken? Less than 20 minutes to whip up this whole frame so far. I don't know how big a camera is, but 20. I think they're a bit bigger than 20. And you want to leave a bit of room, I suppose, for foam or whatever you might want to put there. Let's go, I don't know, 10 in. That looks really far. Let's go 2 million. No, sorry. Yeah, let's go 2 million from there. Then I'm going to go there. I'm going to come back 2 mil. Then I'm going to delete that marking line. Then I'm going to make 1.5 mil circle, a 1.5 mil circle. And then I'm going to do this the funny way. And bam. I'm going to delete. Delete those marking lines. Get rid of this. Get rid of that. And there, we've got some strap holes. So, yeah, the idea being, you can put your GoPro or your Mobius here at the front of the quad and put a strap around. I mean, ideally you probably want to maybe have the arms, or sorry, have the front of the frame come further so you're not hitting the arms, or maybe you want to go for an X design. That will probably actually work much better. This is like a very much a H frame, an H frame, sorry. So yeah, I mean, realistically, I would not get this frame cut out, but you get the idea. Where would I go from here? Probably put some holes to make it a bit lighter, because this is going to be solid otherwise. The other thing you want to consider is you probably want 2 of these bottom plates cut out, because you want one above and one below the arms. Or, you know, the alien frame, I believe that uses one chunky piece rather than 2 pieces. And I think they've got a small piece to tie the arms together in the middle. So yeah, there are a few options as far as that goes. But let's assume for this one we're going to get 2 pieces cut out exactly the same. Just like a ZMR frame, for example. What I'm going to do here is I'm just marking the middle, and then I'm going to draw a big circle, because let's go 17. Because of the way that this is designed, it seems to me like we could cut out a lot of the middle and still keep a lot of strength. You can kind of get more intricate with your cutouts. You can draw different shapes. How do you do that? I can't remember. I did work out how to draw a hexagon at one point. And I've just been copying and pasting that same hexagon for all of my frames. So yeah, that's the other thing. Once you've made one frame, you can copy and paste elements onto your other frames. So that's about the top plate. Let's just assume that I'm not going to use a separate FPV cam. Let's just assume that I'm going to fly through the GoPro or whatever, because that's easier for this demonstration. So I think I probably want the top plate to end about here. Quite often I will actually piggyback the top plate standoffs onto the arms, but I think for this one I might not. So what I start by doing is I mark out my holes for where I'm going to do the top plate. So I'll come up maybe like 8 there. Oops, I hit F1, which is help. Often I do that instead of hitting escape. And I'm going to make a 1.6mm hole there. So I'll come up here and go 8. And a 1.6mm hole. Now, you know, you might want to think about how many standoffs you're going to have. Let's just go 6 for this demonstration, because that's easy. Now where are we going to have this this one, let's go 40, 46 mil. Looks like a pretty good spot. You know what? Just realised I should be mirroring over, because that's going to be way easier. 1.6. I think I want the back to come all the way back here. In fact, see, because we've done that radius there, it puts a point where that radius comes from. I don't know what the terminology is, but that helps us out because that's a good place for the standoff. 1.6 mil, and you know, it's nice and even and everything. 1.6 mil. That's a really good location. I forgot I was going to mirror it over. Looking at this now though, so let's just get a line. In fact, there is a measure tool. Often I use the line instead of the measure tool and then cancel it, but you click there and click there. So that's 124 mil. That's a fair distance between standoffs. Most frames would have more standoffs than that. So realistically, I'd put a standoff there and probably one there, maybe instead of that. So then you've got 4 standoffs across the sides. But yeah, whatever. Let's mirror that. Oh, wrong button. Select those, and then I'll go mirror. And then see, if you move your mouse to the end of the circle and back in the middle, it kind of gives you the option to lock on. Do not erase source object. So there you go. We've got our holes for our standoffs now. Now, what I'm going to do is save. Save as. And then I'm going to save this as top plate. And then I'm going to open the original again. Main. Top plate. So as I was saying, you need all of your elements in a separate drawing. So, and then you can say, I want this drawing cut in this size, etc. Sorry, this thickness, carbon, etc. So this is generally how I roll when I'm doing the top plate. Obviously, we want our top plate to end here, so we can have the GoPro in the front, and the GoPro won't hit the top plate. I mean, we could use massive standoffs if we wanted to clear the GoPro, but that's not what we're going to do here. What I'm going to do is I'm going to draw a circle out to that edge there. And have a line going along here, and that's how I'm going to base the front of the quad. Delete, delete. Have a line like that. So yeah, that's going to be the front. Now I need to get this tool here and get rid of those extra lines. Delete that, and yeah, I need to do the same here. Get rid of those extra lines there. And no, I've got to do this one first, like that, and like that. So we've got ourselves a top plate. Yeah. Now we're going to want to have a battery. We're going to want to have a hole for our SMA for our VTX. So in this quad that I've already designed, I've actually just put all the elements in the same drawing, and I'm going to move them out to different drawings later. So for this one, how big do I do the SMA holes? I mean, you probably want to measure it for yourself and see what gear you've got. That's the great thing about designing your own quads. You can be like, oh, well, I've got this gear here. This is exactly what I need. And you can tailor it to exactly your gear and exactly where you want to place stuff. So 3.5 millimeters is what I do for the SMAs. Let's just do the SMA at the back. That's pretty standard. 60. So let's go 30, and then we'll come up a little bit. I think maybe like, I don't know, 5 mil. I think I said 3.5 for the SMAs. So that's where you can have your SMA at the back on this particular quad if you wanted, for your VTX. And obviously we need some battery strap holes, lines. There's going to be heaps of room in this particular quad because it's 7-inch props. It's a massive body, so it's not going to be aerodynamic. But let's just say it's going to be a cruiser, I guess. Okay. So now you need to think about what battery you're going to use, and probably measure it. Like for this frame, I accounted for the fact that I'm probably going to use a really big battery. So I went a 50 mil distance for the straps. So that's a fair bit. Now I'm going to come down from the SMA a little bit before I do the strap holes. Realistically, you'd probably want the straps in the middle of the battery. Let's just say we're going to go one strap in the middle of the battery. Let's go, I don't know, like... let's start at 50. Now, let's go 25 across. You know what, realistically, you're not going to use a battery that big. I don't think. So I'm going to go less. Let's go 45. Oh, what have you done? It's a dog's breakfast. 40. Let's just go 20. So what I'm also doing is basing it kind of, I don't want to go too close to the edge of the frame. Guess it doesn't matter because you've got all this meat in the middle, but just aesthetically, that's kind of where I was going with that. Let's go along here to maybe like 40. 20. Then come down 40. And 1.5 mil. 1.5 mil. 1.5 mil. 1.5 mil. Okay. What have I done there? Sometimes you do need to go out on both lines before it will lock. It's a bit weird. I should have just mirrored it. I always forget this mirroring technique. It saves a lot of time. So I'm actually going to mirror it instead of finishing that other side. I did a little dot there before. So, delete that and mirror it because that's much quicker. Mirror from that point to over here. Oh crap. What are you talking about? No. Okay, so now we've got some battery straps. For a top plate, you generally probably want to line it up a bit more. Put some, fancy designs in here. I mean, you can do whatever you want. Like, you can draw lines everywhere. You can have a cutout like that if you wanted. Cut that and that in the middle. Oops. But circles are pretty easy and they're strong. So I'm kind of a fan of circles. In fact, what I'm going to do is I'm going to come from this point, so I know I'm exactly in the middle, and I want my circle about there. And I'm going to get the circle tool, and I'm going to draw a big circle like that. And I kind of like doing that in my ZMR Slim frame. I did something like that because then what you can do is you can have your XT60, your battery lead coming out this big hole here, and you've got your battery here, and that way your props are well away from the XT60 lead. There's no way it can be cut because it's going through this big hole in the middle. So that's kind of why I'm a big fan of big holes in the middle of the top plate. You might want to do some intricate designing in here, maybe do some cutouts to lighten it up a little bit. But yeah, that is the top plate done. So I think at this point we've got a quad. We've got a top plate there. We've got our arm, and no, we don't. What we've got to do now, what I'm going to do here is so we've got our, I like to keep this together just for a reference, but what we need to do is get rid of the circles and the arms for getting this cut out. So I'll save this as, what I'm going to do actually is going to save this as complete. So now I've got a copy of it completed, and then I'm going to open that main one, because this is the main body. So delete those extra bits, delete these bits here. I'm just using the delete key to delete things. I'm not sure if I mentioned that, but that's probably kind of important. Sorry. And there you go. So I've got a feeling there's some overlapping lines there. Nope, there's not. See, sometimes you can see there it looks a little bit whiter or something. Sometimes you can see when you've got overlapping lines, but sometimes it's hard to tell. Now, I was saying about little mistakes, like little bits that don't connect properly. How you can tell is if you select everything, and then you type on your keyboard JOIN, join, press enter, and then it says blah 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 blah, and it joins some of it. You've got to do this a few times. You've got to keep doing it, JOIN, join, until it says into one polyline. And now you know. So now you can see that it's joined that nicely. So that's good. This is good. You just kind of look at your elements and make sure they're all joining properly. If you get to a point where you've selected everything, oops, and you type join, and it just will not join it into one piece, then you've got a gap. You've got a problem. So you need to work out. You probably will be able to work out where that is, because that'll be the part where it isn't joining. So now that you've got all of your elements in separate files, what you need to do is save them as DXF files, and no, I've already done that. Oh shit, I don't know, I think I've done that. So now what I'm going to do is I'm going to go to the folder, and I'm going to move those DXF files just into one folder, just for organizational purposes. DXFs. Ugh. DXFs. 1, 2, and 3. So now I've got our folder of DXF files. What I would do now is get up an email, work out where you're going to get it cut from. There are quite a few places on the internet who will cut DXF files into carbon fiber for you. So you attach all these files. You say, please find attached, tutorial quad arm.dxf. Please cut this 4 copies of this from 4mm carbon fiber. Mainplate.dxf. Please cut 2 of these from 1.5mm carbon fiber. Topplate.dxf. Please cut 1 copy of this from 1mm carbon fiber. Then you'll get a quote sent back to you, saying the price. You'll say, yep, sounds good, and you send them the monies, and then you get your frame sent to you in the mail. It's that easy, and it's it's pretty cheap. I mean, it's not as cheap as a Banggood frame because you know they're made in China, mass produced, whatever. But if you can find a good CNC cutter out there, then it's definitely well worth it to get your own custom frame cut. So there you go. I think that's the end of the tutorial. Thank you very much for watching, and hopefully we get to see some creative frames out being created.